Recently, Lockheed Martin announced a breakthrough in low-cost cruise missiles, paving the way for their deployment in the 2030s. In future warfare, the U.S. military may not only rely on Tomahawk cruise missiles and JASSM standoff missiles in initial strikes, but also deploy large numbers of low-cost cruise missiles. Lockheed Martin refers to this low-cost cruise missile as Common Multi-Mission Truck, CMMT. It is a stealthy, subsonic, multi-role munition with high adaptability, capable of being widely deployed on various launch platforms to perform ISR, electronic warfare, and attack missions. It is believed that CMMT is positioned between glide bombs and cruise missiles, filling the range gap between the two. The maximum glide range of guided bombs is about 100 kilometers, while cruise missiles are suitable for attacking targets over 1,000 kilometers away. The weapon that falls between these two is the JASSM stealth standoff missile, but this type of missile is expensive with a unit cost of $2 million. Such a high price makes it difficult for these missiles to be widely used. In combat against Houthi forces, the U.S. military found that while long-range missiles had sufficient range and power, their high cost made it difficult to achieve a numerical advantage. In contrast, the Houthis were able to sustain prolonged attacks with cruise missiles at a much lower cost. Due to concerns about potential conflicts in the Indo-Pacific region, the U.S. military is now increasingly focused on lower-cost, scalable, and rapidly mass-producible air-launched drones and munitions. According to U.S. military estimates, in a future Asia-Pacific battlefield, about 15,000 target points would need to be attacked. Even if JASSM were used to attack 50% of these targets, with an estimated penetration probability of 50%, it would still require 15,000 JASSM missiles. However, in 2024, the U.S. military only procured 550 JASSM missiles, meaning that acquiring 15,000 JASSM would take 30 years and cost $30 billion. If logistical support, technical assistance, and other costs are included, the total expense would be even higher. CMMT was developed precisely to address these issues. This weapon is part of Lockheed Martin Skunk Works Project Carrera, which, through the One LMX initiative, has restructured internal processes, reducing preliminary design review time by 50%, and adopted a distributed supply chain for rapid mass production. Its design draws from the early speed racer drone digital engineering experience, with the prototype having a unit cost of less than $2 million and featuring a modular architecture. Additionally, CMMT shares similarities with Anduril's Barracuda drone, both reflecting the current military-industrial trend of developing low-cost, expendable cruise missiles. Lockheed Martin has introduced rapid manufacturing concepts into CMMT production. One approach is maximizing the use of existing components, which not only controls costs but also fully utilizes current production capacity. Another approach is incorporating modular design, 3D printing, flexible manufacturing, and pulse production lines to enable rapid production, scaling, and mass production, while also allowing the missile's functions and applications to be quickly adapted based on mission requirements. According to Lockheed Martin, CMMT's annual production capacity can reach 2,500 units, meaning that 15,000 units could be completed in just 6 to 7 years. CMMT's biggest advantage is low cost. According to Lockheed Martin, they have reduced CMMT's unit price to $150,000. If 15,000 units were procured, the total procurement cost will be only $2.25 billion. Even including logistical support and technical assistance, the total cost would not exceed $3 billion, which is only 1/10 the cost of JASSM procurement, making it an affordable weapon. Lockheed Martin is currently promoting two basic configurations of CMMT. The first configuration is a baseline missile launched from Air Force fighters, bombers, and transport aircraft. Concept images show CMMT being launched from C-130 series transport aircraft and F-16 fighters. It can be suspended externally or deployed from the rear of a transport aircraft, like the Rapid Dragon system. When launched via the Rapid Dragon airdrop pallet, the pallet size has been redesigned to accommodate smaller munitions, allowing each pallet to carry 25 missiles, compared to 9 JASSM per pallet. A C-17 transport aircraft can airdrop 100 CMMT at once. In early March, CMMT completed a drop test using the latest version of the Rapid Dragon pallet. More pre-flight drop tests are scheduled later this year, followed by the planned free-flight tests. Lockheed Martin has already begun manufacturing live missile components and plans to validate 3 different engine configurations for the missile body this year. At the 2025 Air Force Association Warfare Symposium, Lockheed Martin also showcased a ground-launch version of CMMT, demonstrating a HIMARS launcher firing a booster-equipped CMMT missile. CMMT is approximately 2.44 meters long and features a stealthy design, open architecture, and modular components. Its guidance system, payload, and engine can be quickly swapped, even for a larger fuel tank to extend its range or to switch mission roles rapidly. This means CMMT can be manufactured using a distributed supply chain and production lines to meet customer needs. Additionally, new capabilities can be easily added, such as a maritime strike version with multiple guidance heads for swarm attacks against enemy air defenses, or it can be converted into an air-launched decoy. Future upgrades may include AI-driven guidance and enhanced stealth capabilities. With a range exceeding 800 kilometers, CMMT fills the market gap between low-cost glide bombs, such as JDM, and high-cost cruise missiles, such as JASSM, which costs over $1.5 million per unit. If procured by the U.S. Department of Defense, Lockheed Martin estimates that, once the production line is fully operational, annual output could reach 2,500 units, supporting the Indo-Pacific military strategy. The company also emphasizes a resilient supply chain with multiple suppliers, ensuring that production can be deployed and replicated globally, whether in the U.S. with international partners or directly in conflict zones, allowing for modular, distributed manufacturing and rapid frontline assembly. In summary, the CMMT weapon system aligns with the U.S. Air Force's Replicator initiative, which aims to mass-produce low-cost munitions for sustained high-intensity warfare. Its deployment may extend to forward bases in Guam, Japan, and beyond, significantly impacting the Asia-Pacific security landscape. However, CMMT also comes with trade-offs. Its cost reduction results in lower performance. For example, its range is only half that of a Tomahawk missile, and its payload, attack capability, and electronic countermeasures are also reduced. Analysts believe that CMMT will likely be used for secondary missions on future battlefields, such as attacking lower priority targets or acting as a Pathfinder missile, striking enemy radar stations, communication centers, and logistics hubs to clear the way for follow-on missile strikes.